Assalamualaikum warahmatullahi wabarakatuh. Thank you for me to change the presentation my paper, which is titled Contamination of E. coli bacteria in water distribution network from karst groundwater source. The case study in the Spam-Tuskinjan drinking water network. My name is Eko Budiyanto and my team are Mr. Nugroho Haripurnomo, Musayana, and Aida Kurniawati. We are come from Geographical Education Department, Social Science and Law Faculty, Universitas Negeri Surabaya. The background of the research: karst groundwater is the main source of domestic water for residents in the karst region. Karst groundwater is generally characterized as susceptible to pollution. The nature of the porosity of karst rock that easily pass water can trigger the movement of pollutant quickly. Karst groundwater in general has characteristics that are susceptible to pollution. The karst landscape where its research was carried out is naturally capable of escaping water quickly, as well as having low ability to protect its groundwater against contamination. Colibacteria is a pollutant that is commonly found, especially in water sources in Gunung Sewu karst area, both in surface water and subsurface water. E. coli bacteria are type of biological pollutant that can live in water bodies. Bacteria can thrive in stagnant water bodies or in tissue. This is a regulation of the Minister of Health of the Republic of Indonesia, which regulates the quality of clean water. Water that will be used as clean water or drinking water must be free from the presence of this bacteria. The threshold on the presence of this bacteria, its mean E. coli bacteria, in water is for sanitation hygiene purposes based on Permencus number 32 of 2015 is 0 per 100 milliliter samples. The quality of water for drinking purposes must be seriously considered. Spam-Tuskinjan is a drinking water system for residents in Gunung Sewu karst area that utilize karst groundwater. The system is managed independently by local residents with a simple method. Water is not treated before entering the distribution network. Spam-Tuskinjan supports the water needs of residents in 5 hamlets, which are included in 2 villages, namely Pinjahan Village, Kapanewon Ponjong, and Karangmojo Village, Kapanewon Karangmojo, Gunung Kidul Regency. Water is not treated before entering the distribution network, and karst groundwater is lifted using a pump and stored in one main reservoir. The water is then directly distributed through pipelines to people's homes. This condition allows forward the quality problem, namely contamination of coli bacteria in the Spam-Tuskinjan drinking water system. So the goals of the research are: the first is to explore the information related to the quality of Spam-Tuskinjan drinking water, especially in the E. coli bacteria pollutant. And the second, find out the distribution pattern of the E. coli bacteria in the distribution network system based on the distance of the outlet. And the method of the research are: the first is survey and network mapping. This is carried out by using GIS and terrestrial survey. The second method are sampling data. The sample taken consisted of water at the source and at the outlet with close, medium, and farthest distance. Each of these outlet point classification was taken as many as 2 A6 to 7 samples proportionally by considering their spatial distribution. The sample water was taken using coliform sample plotting according with the direction from the PBTKL Water Laboratory of the Yogyakarta province. And the third method is sampling testing. Sampling testing was carried out in PBTKL PP Water Laboratory of the Yogyakarta province. The parameter tested were equally content parameter. The sample is sent to the laboratory in less than 24 hours in a sample field that is protected from exposure to time and placed in a box. Analysis. Summarize the data from the laboratory analysis into a table of E. coli concentration at each sample point and compare with the table of clean water quality standards and applicable drinking water quality standards. And the second are scatter plot between the distant variable and the E. coli concentration values. This is sample plot from Spumpus outlet. The number of samples is 20 pieces, consisting of samples of outlets near medium, far, and the fastest, and one from the main reservoir. This is results of the research. The first is map of water distribution network of Spumpus. From this mapping, known water is pumped and distributed to people's home using a pipe network. There are various sizes of pipe in the network. Network extensions are carried out using 1-inch and 3/4-inch pipelines as main network. The distribution of water from the network to the customer is carried out with half-inch pipe. The water is distributed by gravitational system. This is the distance measurement results of the sample outlet. The results of the distance measurement shows that the nearest water user outlet point is at a distance of 75 meters, and the farthest is at the distance of about 1,400 meters from the main reservoir. This is a table of concentration of E. coli in the sample. The E. coli bacteria concentration at each sample location was known from the test result of the ILPP Yogyakarta on July 7, 2022. There are contamination of E. coli bacteria in the main reservoir. There are 2 outlet points with a very high concentration. The sample number 2 and sample number 19. There are 6 sample points that shows E. coli concentration values between 0 to 10 coloniform units per 100 milliliters. It means most of the water coming from the Spumpus network are above the threshold of the regulation of the Minister of Health of the Republic of Indonesia number 32 of 2015. research can discuss the presence of E. coli in the main tank indicates a leak of contamination of the groundwater system or in the tank. The presence of E. coli contaminant in drinking water source from karst groundwater is in line with previous studies as Vidyasuti, Reinhardt, and Irsabgila and Vidyasuti. The findings of this study are also in line with Budiyanto and Suarwanto and Matthias, which found E. coli concentration in raw water from the Gunung karst groundwater river system. This is the correlation between outlet distance and E. coli concentration. This value indicates the low correlation between distance and E. coli concentration from each sample outlet. However, the trend line of the scatter plot shows a line that goes up from the bottom left to the top right. This indicates that there is a tendency to increase the concentration of E. coli in line with increase in outlet distance. This condition is slightly different from Sophia, Kakim, and Zahratul, which states the strength of the distance factor to increase the concentration of E. coli. Based on the reference source, it's known that this difference is caused by a large difference in the network. The Kenjahan Spamtus network is a small water distribution network with the farthest distance of only about 1,500 meters. Conclusion: most of the water from the outlet of Spamtus Kenjahan water user doesn't meet the requirement for the water eligibility threshold for sanitation hygiene water needs. Preprocessing is required before being used to remove E. coli contamination. The second, the distance of the outlet to the source doesn't have a strong relationship in increasing the concentration of E. coli at the outlet of Spamtus Kenjahan water use source. Okay, thank you very much.